We're going to try to find the rotational inertia of this disc, and we're going to do it in three different ways. We'll actually have three different values for the rotational inertia of the disc. One of the ways is just going to be 1/2 times the mass of this thing times its radius squared. To get the mass and the radius, there is a knob over here. Just unscrew it so that the mass comes out. And please do not do what I just did. This, if we can look right here, this cannot sit up on the desk, okay, or it should not. Please do not move these rotational inertia devices from here. Leave the base where it is. Even when you're done with the experiment, do not move it, please. All right, get that? Okay. The mass of this guy, you're just going to use the double beam balance. And you're going to put it there, and then you're just going to continually add masses until you have enough to balance it. And we'll have another set of these here. It's somewhere around 4 kilograms. And please do use this. This is a sliding mass that you can use to refine your value, all the way down to 1/10 of a gram. When you get the mass, I'm going to bring this up real nice and close to you. It's very important that you line this axle up when you put it in. And don't crank it down too tightly, just get it snug. Okay? If you crank it down too tightly, you're going to hurt the bearings, and you're also going to have too much friction. So just make it snug, and that it doesn't wiggle around. Mine was probably wiggling too much, so now it's a little better. Then you just simply want to wheel this up, and you're going to hang different masses from this string. You're going to mass the hanger each and every time that you use it. Don't just mass the new masses. Remember that from a previous lab. You want to mass the entire system that's hanging from the string for each run. And like Atwood's machine, you do not need to coordinate the dropping of this mass with the recording from the computer. Just simply make sure the red light on the smart pulley is turned off. And then click record on the computer, then you can let go. And it'll go and it'll get the data. There's a nice little break here on the side. If you can zoom in on that, I don't know how well we can see it. There's a little pin right here, and there's a slot. And you can just rotate it until the pin goes into the slot, and boom, it's spring-loaded. The rubber foot pushes against this wheel, so that effectively it's a brake. You can set up your system, have it all wound up here on this part, not on this one, and then just pull the brake out, and that will release it. So utilize that brake. That'll save a lot of time, make things easier for you. So the second way you're going to get inertia, which we'll call I1, even though it's the second way, is you're going to plot the data of the torque, because each time you put a mass here, you're applying a torque, the torque versus the angular acceleration, which you're going to get from the smart pulley. Okay, it's going to be a calculation based on this data. The last way that you're going to get it is you're going to refine your calculations by considering this mass right here. The first value for 1/2 mr squared said that all this mass was evenly distributed throughout the whole wheel, and that is not true. This mass right here is substantial. You can see how thick it is and how heavy this wheel is. It's got to be a substantial axle. So we need to adjust the calculation for the rotational inertia of the whole thing. The rotational inertia will be 1/2 mr squared minus a corrective value, and that's what you need to work through. You can find the radius of this by using the vernier caliper. You can find the radius of the big disc by using the vernier caliper at the front of the room. Leave this at the front of the room, bring your wheel up to it, same as the mass balance. Do not take either this or the mass balance, the double beam, off the front table. These are very expensive and we don't want them to leave the front table. But you can use the smaller vernier caliper to find this distance. And then don't forget about the plunger. See if I can do this with one hand. Okay. You can use the plunger to find out this distance right here for the axle.